So let's see the implementation of circular header linked list. So the difference between circular linked list and circular header linked list is we will maintain another kind of a pointer which will be pointing to always head, and it also stores the count information. Okay, so it is an extra pointer added to head, that's it. So nothing much difference from that. So it is again implementation of circular linked list, so we have to see that as well. So again I will start with the basic. I will use stdlib because we have to include malloc function, and then I have to create this struct node int data and struct node star temp, next. This is again to create that, and I will create one head node, struct node star head equal to null. Okay, so we have to write code for inserting. I will quickly do that. Anyhow, we are well aware of that. So insert function is sufficient, and I have to give value some x. So before I go here, just writing the skeleton of the program, I will be asking you how many elements you want to insert. Accordingly, we can call that insert function. Let us write the insert function in a different style, where you will be taking always calling the insert function repeatedly. So we will write a logic where it inserts the elements at the beginning, because at the beginning and at end it is same, right? So I'll just have one generic insert function. Now just to the game is to look how this header is working. For that I am taking a generic insert. I will not be implementing the position part. It is same as single linked list. Otherwise rest all is same. Inserting an element in a circular header or circular is same. Only thing you have to just modify the pointer, that is start. Okay, so same way I will be taking another pointer, struct node star start. So what is the type of this start? Again it is of type node. Again we will think about this. See, we are saying start is a node. It is to maintain the count, right? So if that has to maintain a count, it is just a normal variable. It is just a normal integer variable which will be maintaining a count. But the implementation of circular header linked list, it will have something like this. So you will have a start node, then followed by the header node, then followed by the elements. I may have 10, 20 and 30, and then I can have null. This might be the list. So there is a header node. On top of the header node I have a start node. So start node is pointing to header node, and then header node is pointing to 10, 20, 30. But this start node is only to maintain counter. So in this data part I will be always having a counter, or otherwise remaining is same. But when I am saying circular linked list, 30 will again point to head node. 30 will be pointing to head node. So this is just an example to understand the logic. So I have to insert the element. Obviously I have to create a temporary, I have to create the how to insert the element. I have to create a element new node, then of type struct node pointer type malloc function size of struct node. I think everybody is aware of this statement. It is a syntax of malloc function. It is a dynamic memory allocation technique. One of the functions is malloc, which will allocate memory dynamically for this new node. How much size? Size of the struct node. And what should be its type? Its type should be struct node star. It is a pointer kind of a thing. So this one will create that. Then immediately we write new node hyphen data equal to that value x which I am passing to the function, and the new node of next will be initially null. So this statement will try to create a node structure in the memory. This we already know. Then I have to check if the head node is null or not. If the head node is null, it means if there is no element in the list, then head node will be null. So in that case, if head is equal to null, then what I have to do, if head is null means that is the only element, this new node itself is the only element, then simply write head equal to new node, that's it. So new node becomes your head and that is the only element. Okay. Then what is the else part? Else part. See, I have to insert, again this is circular linked list, I have to insert element. Again I am writing basic code ignoring this start. I will bring this start once we completely write the code. I will just introduce this start wherever required once we complete this part at least, that is the circular, then we will add the start node on top of it and we will modify the code. So head is null means this, otherwise what I have to do, I have to create a temporary variable and keep checking it. So let me create another struct node star temp is equal to head. So I am creating a temporary node, so while temp next not equal to null, why? Because I am inserting at the end here. Okay. So that is the logic. What we have to do when you want to insert element, if already 10 is there, you have to insert 20. If there is 20, you have to insert 30. Okay. That's why we are trying to do it here. In circular linked list, I can add at the beginning or at the end, right? Suppose this function is to create a list first. Then we will see, we will write the logic for inserting at any location. Okay, this is just to create node. Okay, this is just to insert elements. This function I will be using to create a existing linked list. Okay, I will be using this for that purpose, right? So when you make head node, in the other case, what you have to do, while temp is equal to next not equal to null, I'll write here temp equal to temp next. So this will iterate and bring it to be the last node. It will iterate and bring the element to be the last node. Now once I reach the last node, what I have to do? Since this is circular linked list, assume there is an element already 10, 20. I am adding element now. So in circular linked list, what should happen? The new element which you are introducing, this new node which you are introducing, we have to check, because this is bringing at the end. Once it brings at the end, so it is same as what we say, new node temp next is equal to new node. So what happened here with this statement? Temp is pointing to the last location. That last location next I am pointing to new node. Okay. Then new nodes next. New node next I should point to head. Why? Then it becomes circular. So when I am connecting this way, see from 30, if 30 is the number inserted, it will point to head node. It means indirectly it is pointing to the beginning of the list. Okay. So that way it will create the, insert the elements into the list. Even if it is at the insert at the end or beginning, we will write display function and see whether it is inserting elements in the sequence or not. Void display. Again I need a temporary pointer to keep traversing always. I'll copy this statement. So I am taking temporary pointer head, and again I have to traverse it like this. This while condition is required. In that I have to simply print cout of temp of data. I'll just put, maybe some, this is sufficient. So what I am doing, while temp next not equal to null, okay, keep printing temp of data, it will display that. Okay, simple function here we have written. So from this I will call insert, what I have to pass here, that is 10, again insert 20, insert 30. Let's take 4 elements. Again, you can always use, instead of writing these 4, I think you are aware of this, you can take one int n and you can take cin of n, that is the number of elements you want to enter. Then you can include one for loop also, something like this, int I equal to 0, I less than n, I plus plus, and then here you can write the value. What is that value? Cin some value. Okay. So this will take, how many values it will take? I will declare another variable value. Now what is this value? This value I have to write here like this. C in value, and then write insert value. So this will call the function, no, repeatedly. It will I0, okay, I less than n is given, that is number of elements you want. You can put a message here, no, tell how many elements you want. So slash n, right. So this will ask me, you can enter the n value. That many times you take one input and you can print the value. You can take the input and you may write number, enter the data part, it meant to say, okay, this way. Otherwise you can also call it like this, whichever is fine. For now, let us comment this and see whether that works. That style we will use it. Okay, so I have to, once I insert the elements, I have to display. So I am calling display, sorry, then we have to write return 0. Let us see if this works. I hope everything is done. It's a simple one. Again, we are not implementing all other operations. Yeah, enter number of elements. Let me say 4. Enter the numbers 10, 20, 30, 40. Something is missing here. Is it expecting something? 10, 20, 30, 40. Then I am calling display. Display struct node star temp equal to head, while temp next not equal to null. See out temp data.
Sir, in display function.
Yes, here temp equal temp next we have to do. Correct. Okay, so this is fine. Now is it working? Only true I will take, 10 and 20. Oh, infinite loop. Yeah, this is circular list, right? So when I want to print it, there is no chance of null. Actually, this is failing. It can never be null. So this is head. When temp next not equal to head, keep moving. Here also it is when temp next not equal to head. Why? Because in circular linked list, after last node there is no null, it is head, right? So that's the change here. So now if I check with 2, that is 10 and 20. It is not printing. Yeah. So again, maybe same mistake somewhere here. Index new node struct dot find data null. If head is equal to null, this is fine. If temp next not equal to head. Initially, for this temp next not equal to head, then temp next. Otherwise, temp next equal to new node equal to new node next equal to head. Temp next not equal to head, temp equal to temp next. Will there be any? It means if there is some element already, one element is there, then my temp is pointing to head. If its next is coming to head again, until that I have to move, or otherwise temp next equal to new
Sir,
node.
the scope of while loop.
This is just
Scope.
this is within this only, right? These two statements. While temp next, you mean to say this while loop, right?
No, sir. Yes, sir.
Any mistake here?
Sir, parenthesis, curly braces will come now
That is not
after.
required. If there is one statement under while loop, that we don't need any open and close. Anyhow, for our satisfaction, let's write that. Struct node, whether it is inserting or not, display is not working. So insert, enter the number set ceiling. Let me write some message here. See out. So insert value, C in value. int value, int n, that is number of elements. Then each time I am taking value. This I am calling insert function with value. It is coming here, insert value, x is coming here. I gave assigned x here. Then this is set fine. Let us check once again. Okay, just a second. Enter the elements 3, enter number 10, 20, 30. It is not taking the third number. Why so? Oh, this for loop, any mistake here? When I use 3, I0, I less than n, I plus plus. This itself is not working. See in value, insert value. Okay, let me now just again I will use our old fashion. At least if this is working fine. Elements inserted. Okay, this is coming, but insert function. Display. Insert 10, 20, 30, 40. Int x. Just a second, let me check it. See here, here when I am inserting a new element, right, when the head is null, then I am making head as new node. Then I have to write new node next, self loop should be there, it should point to head. This is missing. Head is equal to new node next equal head, because we are forming circular. So this was not forming a circular linked list before. And here also, when I am creating a node, this should not be null, it should be always head. Okay, because in circular linked list the logic is that if only 10 is there, then 10 should point to head node. That's why I am creating data x and that I am pointing it to head, because I am assuming it to be inserting at the beginning or end. Now let us see, yeah, 10, 20, 30 inserted. 40, what happened to this? Temp next not equal to head. If temp not equal to head, sorry, temp next, display temp data, temp equal to temp next. If temp next not equal to head, why is it printing only 30? Void display struct node star temp head while temp next not equal to head. Here temp of data true. Temp next, see head is head is my temp, that is at here. From here I am checking whether the heads next, temp next is head. No, it is 10. So I am printing 10. It is going to 20. Is that head? No, it is 30. When I come to 30, is that head? Yes, I am stopping it here, but I am not printing. So should I do something like this? No, I have to print it after only. First I have to print the temp data and then go to next. See out temp of data equal to, while temp next not equal to head. How to stop this? Temp is at a head, temp next not equal to head, then print the data. If I insert more values, one is missing. It means there is some mistake in the logic. Display or insert, let us see. Initially data x, then head, this is fine, this is clear. If head is equal to null, head is equal to new node next to else case, if temp next not equal to head, then temp equal to temp next. temp next equal to new node next equal to, this is also fine, inserting elements. Let me no, print what element is being inserted. Cout x see 20, 30, 40, 50, 60. But when it's printing, okay, it is a list is being created with 1 to 10 to 60, but okay, this is true because here I have to write it also, because for the first node it will be at null. So this time it will give properly. Yeah, elements are inserted, but when I am printing, I am giving only 50. So in display while temp not equal to head, temp next only not equal to head. If I give this, it may throw error. Yes, we have to definitely give temp next. So when while temp next not equal to, do I need to write any check here? If temp is equal to null, then I would say cout list is empty. Else case, this logic should come. While temp next not equal to head, cout temp data, and then go for temp equal to temp next. This is closing, this is closing, this is the function closing. Still it is 50. Insert 60 is happening, but display, what I am calling here, I am giving temp equal to head if temp equal to null, temp next not equal to head. It means that last 60 is not pointing to 10. Sixth node when I am giving here, int x, it is coming here, while temp next not equal to head, temp equal to temp next equal to new node next equal to head. Students, can you just check what is the problem? Maybe small mistake here. Let me check once again. We will try to modify the code to use no, some condition here. I will use do while, do open and then while. Now what will happen here? It will print the first one, then it will check. Okay, that case this may work. Yeah. Oh, still 10, 20, 30, 40. Do, else do, this is the syntax. Cout temp of data, temp equal to temp next, while temp next not equal to head. Still same thing, while temp next, temp of data. Anything did you identify? No. Okay. Do cout temp data, temp equal to temp next, while temp next not equal to head. So I will print the temp of data. It means the list is not empty, there is some temp. So the heads data I will be printing. So that will give me temp of data, then temp equal to temp next. Then I am checking condition if temp next is not equal to head. Then you go back again and print temp of data, temp equal to temp next. Still there is some mistake. So if you see, maybe if I check this case, if temp not equal to head, yes, so we got this 60, this should be temp not equal to head. So we inserted in a circular linked list, we got it. Now I was talking about circular header linked list, we have to have a start node. Okay, so for that I have created a start node here. What is the start node? See, in circular header linked list, start node should point to head node, and it will maintain a counter. In the data part of this will be a counter, which will be always doing count plus plus and storing a value. So it is as simple as that. When you are creating a new node, initially you have to create the start node. It is a fixed one, right? So before creating head node does not contain anything. The data of head node is empty, okay, or in the sense this is logically existing. If I delete this and say, see, this 10 is my head node, that head is logically existing, that's it, okay. Start node is there, then head node is at 10. So this 30 will be pointing to 10 only. Actually it means head node is like this, for all list it is the same. So when I say head node is not a separate node, if you want to still create a separate node, you can create a pointer, but the data part of this will be empty. So start node will, it's a node, it will point to head node will point to 10, and these things will be pointed to head node. Okay, so we are trying to create that head node separately. So this node should be separately created. So same way, start node we have to separately create. So it is same as creating a new node. It is same as creating a new node. So what I can do for a start node, we can write a logic to create start node, right? So for that one-time activity, it is one-time activity creating a start node. So maybe I can write a function to create start. I can have some function like this with some do I need that, we will see. So when I write create start, it will create a node structure where it has two parts. Data part will maintain the counter number of elements, and the next part will maintain the next address. If start node's next is null, it means the linked list is empty. Then start node's next can point to head node. Start node next can point to head node. Okay, so that way we can create this. So create start can be a function. It means again I have to create a node structure. It can be something like this. Okay, create node. I'll write here start node. Start node. So this is created. Now start node's data will be, this will be first initially 0. Okay, and start nodes, this will be null. So when I do these three things, create start, a node is created. With this, an empty node with the start will be created. After this, what I have to do, when I am inserting functions, I will write here create start, right. I will do this. So this will be creating a start node. This is fine. Then we have to insert. When you are inserting element, assume this is the case. This again, this is common thing. These three strings are common to create new node. If head node is null, if the head is null, okay. So again, head is again logically pointing to 10 only. Head is logically pointing to 10, right. So if this is null means there is no element. So you can say head node equal to new node, and new node next equal to head, right. So it means you are creating. Then you can have start node. Here you can write start node next equal to head. Head might be null. I will write it head here. Why? Because it should point to head. If there is no element, head will, since head is null, definitely the start node also will be pointing to null. If there is an element, that time head will not be null. If there is an element 10, then head will not be null. Then in that case, since head is not equal to null, you will be creating head equal to head node, new node equal to this link you have created, start node data equal to count plus plus. Okay, start node data equal to count, maybe count plus plus, yes, that is also true. Whenever you are inserting, you will increment it. Okay, you will increment it and store it. So let the count value be 1 initially. So I have to declare a variable int count as a global variable equal to 1. Okay, so this count I am incrementing and storing it here. Later I am doing plus plus, right. So here also I have to write the same thing. Whenever I am inserting a new element, I have to do the count plus plus. Next, when I am printing, I have to print display. The list is empty, okay. When you are printing this while loop, after display, here in do or in else part, I will write cout the number of elements in the list is start node hyphen data. So it will throw error. Let us see whether it throws error or not, because there is chance that it will tell I do not know what is start node. So we may have to pass that. So create start. Let me say what it says. Yeah, I do not know start node. Let I define it start. Start node. Start node, then start node true, start node again true, start node was declared, not declared in the scope. What does it do? It's not asking anything. It should ask create start. Once I am creating a start, this is fine, this is 0, and so start node, this is fine, data 0 is pointing to head initially itself. So head is null, so it is pointing to some null pointer, assume that way. Then in insert, after creating these things, I am creating a temporary pointer. If head is null, then new node head equal to new node next to head, start node's data equal to count plus plus, else start node's data count plus plus. Count is a variable, right? What it is doing? Start node created, this is fine. After that, insert is not working. So when I go here, new node, this is fine. Element inserted is not coming. Head is not null, because there is already start node which is pointing to head. But anyway, we are not okay. Before this, head is already a pointer with null. So it is pointing to null only. Let's put it null. Then once I insert an element, let us check now. No. Create start. This is fine. Start node created. Then I am calling insert 10. In insert, the only changes I made here was bringing this statement. If I remove this, let us check, is it inserting the elements or not? Yeah, it is inserting, but display is not working. So in display, this is pointing to head, temp null equal to null, the number of elements, display function, create start. Just a second. Yeah, please see, the change here was actually we have created a start node here. Okay, again I was putting here struct node star. So what is happening here? There is already a variable, a global variable start node. Again I am creating a local variable start node. So this is wrong, because it should always point to the, we should not create head node again once you declare it here. So that's the only change I have made. So this is clearly inserting elements. You see, it is giving me the output start node created, which I gave, inserted, the number of elements in the list is 6. I am maintaining a counter now, right? So that start data, that start is maintaining, the start node is maintaining the counter, that is initially 0, and I am having a count 1. It is nicely counting. See, start node data equal to count plus plus, and it is checking those. I don't need this also. So when we call if this case, if I remove this and check, so number of elements in the list is 5. These are the elements. Okay. On top of this, you can write, now we will do one task. We will try to delete a node and check if the start count is changing or not. That is what we have to verify. So we will write a function to delete the code, and then we will verify whether it is decreasing the count or not. After display, we will again delete it and check. So I will be writing some delete node, delete function. Okay. So assume I am deleting at the beginning. Let us write a logic to delete at the beginning. So we will check whether the count is coming down or not. Elements before deletion, display, then delete, then again elements after deletion, display. Okay. So let us write a function delete, right? So void delete. What I have to do? I have to again create a temporary pointer. So again I am implementing the logic of deleting a node at the end or beginning. Okay. So we have theoretically discussed in the previous sessions how do we delete a node in a circular linked list. Same circular header or circular linked list, right? So struct node star temp equal to head, right? Now what I have to do? I have to delete an element at the beginning. So the logic here is, see, in this list I want to delete 10 or it is 30, it is same, because this is circular linked list. Whether you delete 10 or whether you delete 30, it is same. So it is as simple as that. Simply you point the start node, right? Start node should point to not to head this time, it should point to head next. Okay. So I have created temporary pointer temp, this is pointing to my head. Okay. So I want to delete, I want to just move temp equal to temp next. I should make my head equal to temp next. So what is it doing? When my this head is at 10, I am saying make 20, temp next means 20, make 20 as my head, make 20 as my head. When I make 20 as my head, so 30 is next is pointing to head, means it will point to 20. 30 is next is pointing to head, means it is pointing to 20. And this temp I have to free it, and also I have to decrease the count in start node. Okay. So in delete head, again we have tried the base case that if there is no element we have to throw that error, but let us verify, since we are already writing after creating certain elements, only then I am deleting. So let us see the base case. So delete, I am doing head equal to temp next. So second element becomes my head now. After this what I have to do? The start nodes data I have to reduce it. The start nodes data I have to do minus count. Okay. So it will reduce one count, right? Base case again a simple one, and also I have to do the free the temp. I have to free the temp. So that it is deleting, whether if you don't write also fine, but it has to delete there from the memory. Okay. So temporary, let us verify once again, struct node star temp equal head. So I am creating a temporary pointer that is pointing to head node, and then head equal to temp next. Head temp next, this is temp means temp next I am making it as head. So obviously 30 will point to 20. Okay, and start node will also point to 20. Then start nodes data I am reducing the counter here, reducing the counter, minus the count, right? So whatever was there in count, that will be reduced and placed into the data, or you can write start node data equal to start node data minus 1. Okay. So we can write it that way also. Instead of doing this, let us not whenever you call delete, you have to reduce number 1. So let us not do that. Start node equal to minus or start node minus equal to start node data 1, right? What is the meaning? Start node data equal to start node data minus 1. Whatever is the value in that, reduce it by minus 1. So let me check whether it is deleting the element or not. Unidentified qualifier, where no delete, in function int main, round bracket, extra round bracket has come. Display delete, where is this? Void delete. Any mistake here? Void delete, struct node, expected primary expression, delete, delete, true. What is expected here? All semicolons given. Expected qualifier ID before delete. Something wrong in this program. Here, see out elements before deletion, endl display, then delete function, then see out elements after deletion, again display function. What is this? Void delete, no mistake. Open and close. This is closed string of void insert, properly closed. Delete. Students, check what is the mistake here. It's saying unqualified primary expression before token. Everything neatly create, start, semicolon, semicolon, given here, semicolon, again semicolon, true, display, delete, see out, display. Oh, I understood. What is the problem? You know, there is a delete keyword in C++. Okay, that's why it is being highlighted. There is a delete keyword in C++. That's why it is saying, I don't understand what is this delete, right? Infinite display. I should not be calling this delete node. Now let us see. Start node create element before deletion. The number of elements in the list is 5. That is this, elements after deletion, number of element is 5. Okay. So delete node function, delete node function. Again, let me write that basic check. Sorry. What is that check? If head is equal to null, then I have to say cout list is empty. Otherwise, I will be creating this. I can write it outside. Then head is equal to what I am doing here. Head equal to temp next. Can I say temp equal to temp next and head equal to no, that I should not do, because I have to delete temp. So I will write head equal to temp next. So that becomes my head. Start node data -1 and free temp. What else should I do here? I am just shifting this, deleting this 10. So 30 will be pointing to 20. So should I always say 30 is pointing to head only, right? Okay, it's going infinite loop. After delete node, let me check this. What is the mistake here? Let's see what happens here. So in the delete function, right? Yeah, in delete node, instead of this, what if I delete at the end? See, the last node 30, it is pointing to head node. 30 is pointing to head node. So even if it is same as deleting 30, right? It is same as deleting 30. That will also delete the beginning element because it is circular linked list. Let us try that and see. Let me check while temp next not equal to head, do temp equal to temp next. After this, I have to write temp equal temp next. Now I have reached the last node. So temp head is equal to temp next. Before this, what should I do? I want to delete this 30, maybe just the case, if I want to delete 30, this node should point to head. So, for that, do I need a pointer? Do this, head is equal to temp next. Head is equal to temp next. Yes?
We will use two-pointer approach.
That's what I am thinking. But again, is there any simplest way? Delete node, temp equal to temp next equal to head. This is again why that should work. I am unable to delete the node. Let me check it once again. See here, in the circular linked list, when I am deleting 10, then I have to make sure that this 30 is pointing to 20, right, or 30 is pointing to head. That I have to make sure. That one logic we are not writing here. When I am deleting 30 also, I have to make sure that this 20 is pointing to head. Okay. So, for that, in delete, I will traverse it till the end. After that, let me create another node, struct node star p, which is again pointing to head. Now, I have to write the temp next should point to head next. Okay, temp next should point to head next, and then head equal to head next. Okay, this if I do, yeah. Now the elements before deletion, it is number of element 10, 2, 3, 1, 10, 20, 30, 40, 50. Elements after deletion, it is 4, that is 20, 30, 40, 50. Now we are able to delete. Since it is circular, whether you delete 10 or 50, it is same. Okay, you can delete in circular linked list, you can delete the node at the end. For the end, again you have to maintain two-pointer approach, you can delete this 50. So, you can write two logic this. So, I hope you understood this. I am pasting this code in the chat box.